We are a little bit behind time, so I'm just going to start this, then we can take the break and I will continue afterwards. So, pipes and filters. We will look at redirection at pipes for combining multiple commands. We are filtering output, and variables and environment variables is what we're going to look at here. You may ask, how do I redirect the output? How do I pass the output that I get from one command directly to another command? How do I combine multiple commands, sort and filter output, and what are environment variables? And these are the things we are going to look at here. First, there are some commands that are useful. They are called less, more, and cat. And they are used to let you look into a file. And it's a good idea to introduce them now, because we are going to use them partially here later in this example here. So more is forward navigation, limited backward navigation in a file with more on the file. Less forward and backward navigation, and it also has search options so less a file. Cat is a tool to do various file-related operations. You can view, concatenate, create, copy, merge, and manipulate file contents. Cat file or cat some options file. Man cat gives you useful options, but let's try and go into something where we can look at. Let's go to patterns. Here there is a lot of files, and many of them are empty, but not all of them. Let's take a look at the file myfile3.txt, and I'm going to use more to do so. And it was short, so it just output all of it. Let's try do less. Less will keep it open. If it was longer, you could scroll up and down in it with arrow up and down, and you could search by entering a slash and the thing you search for. It will show you, jump to that. You exit it with Q. If you just say cat on a file, it just outputs it to screen. The command echo, again, is also something that I'm going to use here. So I will also introduce that, even though those commands, that command and also less, etc., are not really related to pipes and filters, but I need them, so I'm introducing them. The echo command in Linux is a built-in command allowing users to display lines of text or strings passed as arguments. You often use it in shell scripts and batch files to output status text to the screen or file. Because if you said echo, this is a line of text in apostrophes, quotation marks, sorry, then it outputs whatever is inside there as this is a line of text. You can give options to it, but it's most often just used like this. But try it. Try echo something. Hello, my name is Birgitte, and things like that. And you could use it, for instance, in a script. So it says, now converting all the files to all the image files or something like that. So it tells the user of the program what it's doing while it is sitting there and doing something. So what is redirection? I/O redirection, usually standard input comes from the keyboard, standard output goes to screen. There's also something called standard error. you can redirect all of those with Linux commands. If you use this larger than, it redirects the output of a command. For instance, ls larger than test.dat. That would send the output of ls into a file, and that is often useful. If you give some long command and you get some output you want to save, then you can do it that way. If you put these two larger thans together, it concatenates the output to what was already there. So, for instance, if I say ls, I have these. I'm going to do ls, and I'm going to say my output, a text. And now I'm going to show you what is in my output text. It is output of ls. And you could see this is the stuff that came out of ls. If you want to concatenate to it, you could do like that here. Now this will have the output twice. And if you instead use less than, it changes the standard input to larger than will redirect the standard error. So if you, for instance, get some errors output from my program and you want to throw them to error.log, then you would say my program to larger than error.log. / in front of a program will tell the shell to execute the program, my program, if it is located in the current directory and if it is executable. This is very commonly used. 2 larger than and 1. It simply means it redirects both the standard output 1 and the standard error 2 to the same. So if you want all the output, errors and everything from my program sent to a log file, then you would say this for to run my program, this here, larger than, redirect, and you want it sent to log file, and then you tell it, I want you to take both the standard output and the standard error and put into it. And let's just try some of these things. We have the myfile.3, and you see the text there. And what if I then say cat that stuff and then sends it to a file, my new file text, then it got the content that was in myfile3. See, it's the same that's in there. I could also send some text. This is some text. And then I would like to append it to my file, my new file. Like that. And let's see what is now in it. It also has the line, this is some text. And that is quite useful. You can also use this command, but this is actually the most common way of throwing text to a file in many programs and scripts. So, and what then if you wanted to add a longer block of text? Well, you can do that by just opening the file for writing with cat. I will do clear so that you can easier see what's going on. and I will say cat, and then I will say that I redirect to, for instance, foo.text. It now is open for writing. I will say I am going to put some text. This will be more text. It is really snowing outside. It is almost a blizzard. Like that. And then I want to save this. I do that by pressing Control D. And when you see a command like that, it means press down the Control key. And while you are holding it, also press D. Like that. And then it exits. And there should now be a file called foo.txt. There is one. I'm going to see what is inside of it. And there is the stuff that I just put there. I didn't add a new line at the end, so it didn't add one. So you have to add those in order to actually get them. Then there are the commands head and tail. They are also very often used. And I'm just going to talk about those, and then I will take the break. So head will show you the first lines of a file. So if you say head -3 and then my file 3.txt, it puts out the 3 first lines. If you instead say tail, it will give you the 3 last lines of it. And you can play with this file here in the exercises patterns directory. And I suggest that we take the break now until okay, let's continue. So let's look at some commands to count words and to sort. There is a command called WC. It's a word count command. It counts number of lines, words, and characters in files. And it will return the values in that order from left to right. And you can give some options to it. -L, then it will only list number of lines per file. And -M is only characters. -W is only words. So in this example, I have run it undefined, and my username on that one is BBRYDSOE. But I'm also going to show it here on Tetralit, and I'm going to work in the exercises patterns directory again. And that is the one that you got from the tarball you downloaded. So if you want to code along, then go into the exercises directory and into the patterns directory. And then let's try look at the files. We have one called myfile1.txt. I'm going to try and do word count on that. And I get 3 numbers. And it is telling me there are 4 lines, there are 15 words, and there are 80 characters. Let's try look at the file. Like this. And you can see there are indeed 4 lines. And it sounds right, there are 15 words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And probably 80 characters. So you could try do that. And if I say I would like to do word count on all the text files, so let's try do that. Then it lists all the text files one by one. It tells me how many lines, how many words, how many characters. And it also sums them. You see, this could be useful. And what if I only want to know how many lines they have? Then I give the option -L for lines. And let's look at my file 2, the text. It has 2 lines. And if you just say WC, you won't get any input. It is waiting for input because you have to give it some input. And to escape something like this, you hold down Control while you press C. So how do you capture the output from this word count command? Because what if you had a lot of files you wanted to look at? You can see here, just in this directory, it was a sizable number. What if you have hundreds of files? Then maybe it's better to actually throw the output to a file or redirect it to a file. So I will take the word count command. I will ask for number of lines. And then I will say that I want that for all the text files in this directory. And then I will throw it to file length. The text. Now I should have a file called file length.txt. And there is indeed such a file. I am doing cat on it. And you can see it's fairly long. But if it's many hundreds of lines, then maybe you don't want to use cat. Maybe you want to use less instead, because then remember, you can scroll in it. Then there is command called sort. The sort command is used in Linux to print the output of a file in given order. If you use the option -N, it compares according to string numerical value. -F ignores case and -B ignores leading blanks. There are more options, and you can find them with man sort. So I'm going to look at the file numbers in the exercises patterns. It is this file. I'm just going to, with less, show you how this looks. It just has some numbers in it. So I will run sort numbers text. And it sorts them, but it has the default alphanumerical sorting. So it sorts them by first the first character and then the second and so on. And that's not usually how you want it sorted, or maybe it is, but if you want it numerically sorted, then you give the flag or the option -N. Then it outputs it sorted the way you probably expect it to do. What if we take the output from the file length.txt, the file length text that we got as output from the word count above? We can sort that, of course. So let's do that. And then it sorts it by the numbers it sees in it here, and it again gives a total. Because it was the total that it was at the end. So it simply sorted lines by the numbers it saw in it. And you could, of course, have done this in just one line, and let's talk about that under pipes. Pipes are also a type of redirection, and you use them when you want to take the output of one command and use it as input for another command. It's often called to pass output to another command. And if you wanted to do these commands in one line, you could do the word count and then sort it like this here. And I'm going to do that example. And it's very often possible to do the same thing with intermediate files as we did here with sorting on the file length. But it's often better to just combine the commands with one or more pipes. And the pipe is symbolized by this straight line between the commands. And we are again going to use the exercises patterns directory for this. I'm going to type clear in order to have more space to show how it looks here. So first I'm going to show the output I got from sorting the file length file. And now I'm instead going to take this command here, word count -L for lines. I'm going to take all the text files, and then I'm going to pipe the output not to a file but to the command sort -N. And in this case it outputs these things. And the reason there is a difference is because while I did this here, I did it on the file length.txt, and file length.txt does not have the content, the length of it itself in it, because it was created by sorting the files. So this is the same, but with the addition of the file length.txt. We can use tail on the output if we want to see only some of it. So let's do tail -3. Then we only get to see some of it. If we want to see the beginning of it, then we use head. As you can see, it's not sorted. We could sort it. So I'm using again arrow up to find my command from before, where I did the word count on the text file lines. And then I sort it. And then I take that output and I pass yet again to another command, namely head and the 3 first lines. Now the files are sorted. So you have the empty files at the top. If I instead did tail, you will get the ones that with most lines at the bottom, and also the word 122 total, because word count outputs that. And you can see here that you can do quite powerful commands very quickly with this. So it is time to talk about exporting variables. Variables can be very useful. There are environment variables that are used to store data used by the operating system and other programs. Some are intrinsic to the operating system, some are for specific programs or libraries, programming languages, or maybe even created by the user. And these variables can be used in scripts, and they can be used on the command line. And you usually reference them by putting a special symbol in front of them or around them. And environment variables are in uppercase. You have already met one that was $home, which is a variable, an environment variable that contains the location of your home directory. There is $pwd, which contains your current directory. There is for LD library path. This is a colon-separated list of directories that the dynamic linker uses when it searches for shared objects before searching in any other directories. You use that often if you are compiling something. Maybe you want to set number of OMP threads. You do that with an environment variables. If you're using Python, maybe you want to set the Python path to the directory where your Python libraries and packages are installed. These are just some examples. And if you want to see the content of an environment variable, then you echo $ this environment variables. So I could echo, for instance, the one that is $home. For me, it contains home / my username. I could say echo and then $pwd. It contains the path to my current directory, and it is the same as I get from pwd, of course. So if you want to see a long list of all the environment variables, you can use env. And then it will list some variables up here, as you can see. There is, for instance, one that's called snick site. It is snick was what was before NAISS, and it simply is used as a variable that contains the name of the site you are at, and this is NSC. And it also has the user, that is me. And if you want to address this, you use a $ in front of it. So echo $user, it's me, my username. And there are some environment variables you need to export in order to use them. And this is done like this on the bash shell and like this on shells related to CSH. And an example of something that needs to be exported could be the Python path or the OMP num threads, or a library path if you have installed some library and wants to include the path to that to the library path that program searches. Note the environment variable only retains the value you have set for the duration of the session. When you open a new terminal window, when you log in again, you need to set it again. If you want to avoid that, put it into the file that's called .bashrc. That is a file that contains some configuration for what should happen when you open a new terminal or log in. And you can add quickly a new directory to LD library path like this. This is just an example, but you can see it again uses this echo command, and then it uses this export the variable to what you want it to be. It concatenates it to your file bashrc. So this is again a combined command you could do on the command line. And then there's a short list here of key points of things that you have gone through here. I'm instead going to go directly to